Um, okay, so I would like to wrap up what I did on Monday regarding the difference between set quantity by value, set quantity by reference, and set quantity by pointer. I think this is mixing between both the C++ world while we have the difference between the object and the object reference. What exactly is the difference? And also this kind of reconnect us with the concept of C pointer, which is address. In fact, these two have a lot of connection. It's just different representation. After the class, I realized it's interesting. It's always like after you're programming for the same programming language for such a long time, you start to seeing a different way of interpreting what we're dealing with as a C++ programmer. So some of you might already realize this, but anyway, I'm going to say it, is that the view of a C++ programmer versus the view of a Python or Java programmer, they're different. They're a different view in the sense that in C and C++ programmer, we need to be aware of the physical memory, the memory where it is. Why? Because we need to access the memory address from time to time. And this is the both introduce some kind of challenge as a programmer, but also provide a different way about interpret what we're doing programming related to object versus object reference. So one of the things I would like to show you is that I said the difference between call by value versus call by reference, meaning that you add that n at the end of the time, right? That's basically at the end of the time, you change the data type of that particular argument, try to pass into the function. So if I said the difference between those two, one of the major one is I need to make a copy of the original object, right? That's the difference between object reference and call by value. Is call by value, you always have to make a copy. But if you do reference, then you're not going to make a copy. So what does that mean for the physical memory view about a C programmer? Is that if I actually make a copy, think about this. If you make a copy of something, then you're going to see a different memory address in your physical memory. Does that make sense? If you actually don't need to make a copy, like a reference, then the memory address should be the same. So this is the advantage of C programmer or C++ programmer. Then we can try to print the address within the function and outside the function and see if they are the same or different. All right, so that's why I add this two line. By the way, I already uploaded this to GitHub as well. I feel this is good for you to see different way to prove, to verify what you're doing. Yes. This one is object reference.cpp. It should be under CPP01. Okay, object reference.cpp. So you can see I add this two line here. Let's look at this, how I can print the address of that particular object. So here we say the item ecs36b underscore item, right? That's the argument. First argument being passed in. And because I don't have an n sign here, so this must have induced a copying. And so it must, the underscore item as a variable is a copy of the original one, which means that it is going to be on a different address. And therefore, I'm going to print the address of items. So here's a way I not only print the item's address, but also I print one of the member, which is quantity, is a one of the member from the item. I will also print that address as well. I mean, the more you print, the more you can be sure. Yes.
So let's say like when you're passing in that call by value of item, you're making a copy of that entire class, of the entire object, right?
Correct.
There was more than one member. Like let's say there was quantity, but then there was like another variable in there that had another integer value. If you did call by value, it would create a copy of every single member of that.
Exactly. You're going to copy, if you have a 5 attribute, you're going to copy all 5 of them. Yeah. Okay. Good question. All right. So over here, I only print 2 address. By the way, refer also to your question. Later, we'll learn there is a compiler tool to help us generate the memory layout. And I mean, that's only available to C++ programmer. You will see clearly how the whole memory together. So let's look at the syntax. But how do I print the address? So for item, I'm just basically put the and sign in front. Okay, so last time, oh, it's already erased. Anyway, so this and sign, if it's a before a variable, then is represent an address. But this M sign is after a data type, like later you will see down there, then is a part of the data type itself. Okay, so and item, this means that this is the address. By the way, I just want to tell you, since we start to talk about the C++ IO string, we use the std cout. If you want to do this in printf, you are going to need to do this. Printf. I'm just going to put it here for your reference. You're going to put a %p and put a \n and then put a com. Okay, these two, they're doing the same thing, but this is the traditional printf style, stdio, but this is the IO string. Okay, is your choice about which one you think is better. Yeah.
Question, do you recommend us using namespace std?
Yeah, I think this is, well, then I have to tell you, I kind of like it, but I kind of don't like it as well. The idea of using namespace std means that you no longer need to add std colon, which, in my opinion, sometimes make the code less specific. Because if I do like this, I mean, it's a 5 extra character that I put it there, 6 characters actually. So in the std, it's not too many characters. I put it here, but it's clearly told me that this is from the standard library. Okay. In fact, the compiler doesn't matter. It's going to be optimized. This is not going to cost you anything to do with the performance, just readability. So using namespace, I sometimes feel, yeah, you save some trouble about writing certain things. On the other hand, you kind of lost some of the availability. There was a hand back there, that direction. Okay. Right. All right. So I'm going to. That's why you see that I most of my code I actually put std colon in front of everything. Okay. All right. So I'm going to print this too. One second, and then for the quantity, I just say underscore item dot quantity, and again I parenthesis and put the and sign. That means the address. Yes.
What %d? I thought I just was a number. So maybe %d.
Yeah, %d is a number. %p is a pointer. So the difference is that if you put the %d, you will get usually will get first you might get a warning. Because is a pointer, you try to print it as an integer. And the second, the value you're going to see is going to be decimal. It's a 10 base number. Instead of if I put %p, is going to be hexadecimal, which is a 16 base, which is for address, sometimes it's easier for us to recognize. Yeah.
It's not a pointer, the I. Or the ampersand, it's just like the physical location of memory, right? So
right, that's right. Well, but in C, I just want to clarify. In C, address is a pointer.
oh,
Address is pointer. So that's when we print pointer itself, it's really printing the address. All right. Okay. So any other question? Okay, so let's take a look. Another example. This 2 line is identical. Over here, you see that I'm doing set quantity by reference. And you can see I'm doing the two line as well, right? That's the item. Now the difference is that this one is n. That means the reference, I'm not going to make a copy when I print this average. I want to see the contrast, right? To see if whether we get, and then of course I add another two line, which is for the set quantity by pointer, which you can see that instead of n, I'm actually putting the star item PDR. Over here it's a little bit different, but it's still similar. You see what I'm doing? I'm doing underscore item PDR. Because why? Because this is already a pointer, which means already address. I don't need to add that n sign. All right, so I just put it like this. And then the member of the quantity, what I did is I do item PTR pointing to the quantity and put the whole thing and then put an n sign. Okay, if you're not really familiar with a pointer syntax, that this example actually gives you some good example you can kind of play around. So I'm not adding all the things here. Okay, so let's try to do a print. But the other thing what I did is that before, remember this is my original object, my item. So what I did is I print the whatever the address here as well. So you can see that I'm printing my item and my item dot quantity n. So I just want to tell you that before you call the function, what was the address of those things? And then you're going to call by value, call by reference. I want to see the difference. Okay, so let's try to run it. You know what? I'm going to run it over here. It's easier for me to use, for you to see the code while you're running this. I think I'm going to compile it anyway. G++ minus minus std is equal to C++ 14. Okay, and then is object reference dot cpp. Okay, and then I'm going to run a out. All right, I got a bunch of addresses. Okay, now you can see that everything starting with the value of where's my mouse? Oh, so here. Everything starts with 0x. If you use a %p in traditional C++, or you're using IOString, which you say I want to print a print pointer, is by default is going to print the pointer format hexadecimal. Whenever you have hexadecimal, they're going to put the 0x in front. Okay, that's just notation. So let's try to see the first two. These two are the original object before you make the call. So just remember that's 16B5AF298. Okay, so now remember the first pair. The first pair is what? It's called by value, right? The first pair of address that we have. Let's take a look at the program. Just be careful about this. So here's the main program. The first pair I print was the original object item and member quantity. And then you can see the first one I call is set quantity by value. Okay, anybody can tell us when I do set quantity by value, do we need to do a copy of the object? Yes, right? Call by value is always make a copy. So now I make a copy of that variable. So now let's actually look at the second pair. So this is generated. These two lines are generated by the set quantity by value. So you can see the address is different. One is 298 and 2B0. And then the second one is 268 and 280. Okay, by the way, have you noticed something? I said, what's the size of the string? The size of the STD string is 24. Okay, why did I do that? Let's actually show you why I said this. So if you go up all the way to this class, you see that it has how many variables? 2 variables. Okay, so an object has the object really have a 2 variable. So the first variable is what? Is a STD string. And I just show you the size of a STD string in the C++ representation on this machine is 24 bytes. And then the second one is quantity. What does that mean? That means the address between the pointer to the object and the pointer to the quantity should be difference by 24. Okay, so now let's actually take a look at this too. You need to be familiar with hexadecimal. If you compare this two between here and here, is exactly 24. Okay, the difference is 24 because let me just show you what's so 98 plus 16 is what? 98 hexadecimal plus 16 is 8, letter A alpha, A8. So 98 plus 16 is A8. And then A8 plus another 8, that's what? That's B0. That's why is 298 and the 2B0. So now you know, I think one of you asked the question. That's the second argument. So not only you can see the address is different, but also it makes sense. Is actually the quantity address. So similar between those two, if you subtract this two in the hexadecimal, it's going to be 24 exactly. So now let's take a look at the second one. The second one, the third pair is actually the reference, right? The call by reference. So if everything is correct, that this should be identical to the original one because I didn't make a copy, right? The address should be the same. So that's exactly the same. These two are the same as the first two, right? So that's the way you have assurance that, oh, we really didn't make a copy. The address I'm using for call by reference is original address, means that they share the same memory cell. That means within the function that I change that memory cell is going to change original object. So that's why it's called call by reference. And more, you can take a look at this. What's this? This is call by pointer. I'm using the C style pointer. Take a look. The value is exactly the same. It's also the original one. So that's why I'm saying that if you do call by reference, means that you add and sign as the argument type, versus you use the in the argument you use the star, like ecs36b underscore item star. That is also give you the same address. Okay, so this kind of show you not only you now know the difference between call by value, call by reference, and call by pointer, and also tell you that call by reference and call by pointer, they're identical. They're essentially the same thing, but just different syntax representation. And also, what I hope you will learn is that as a C++ programmer, sometimes it will help you if you try to print the address within your program, so you can to verify such kind of concept on computer as well. Okay. Okay. Any question? Yes, please.
So if the address when we're calling by reference and calling by pointer is the original cell, does that mean this is just like the compiler, it first compiled it normally, so it's 0, and then it compiled the reference, so it's 1,000, then it compiled the pointer, which is 3,000. So does that mean that right now, currently, the quantity would be 3,000 inside that memory?
Yes.
Okay.
Yes. In fact, you can do that. Let's refer to the question. Let me try to do this. Yes, I want to kill it. That's just one. I just want to write one line of code to show this. So remember, I set the value to be 3,000 over this line, right? All right. So let me add one more line here. I said, okay, the value of a quantity is Okay, right now I'm not going to directly print out the item pointer quantity. So what I'm going to do is item pointer, I said plus 24. So I'm adding address difference, right? This is the original address, I plus 24. Let me see if it allow me to do that, but I just want to make it, yeah, it should be okay. So now I have the address and then I dereference. So I think I need to do this to avoid some compiler warning. I casting this with a pointer type and whatever value that was. Okay, so you can see that what I'm doing is I look at the address, I plus 24, which give me the address of the quantity, and then I do a dereference at the star. Let me see, what do I got? I'm expecting some warning. Okay, let me see, what was the warning I'm getting? What's the arrow actually? It's giving me an arrow. Okay, it's complaining about that. All right, I will do this. I'm going to do adding more casting. That's the C++ programmer. I have to do this. So I'm actually going to change this to be long. I'm going to cast this. I'm casting to a long, and then I plus the 4. Is this looks okay? All right, let me see if this will work. Still have an arrow? What did I do? What's arrow? Invalid operand to binary basic string. Oh, okay. If you don't like that. No, I think I know what mistake I made. This is not the pointer to the item, but this is the, because it's a quantity, so it should be integer star. Okay, now I can work and dot slash a out. Okay, now you see that the last part of the quantity, if I print it out, no, sorry, this line, right? The value of the quantity is 3,000. That's how I actually look at the address. I'm not using the quantity, I'm using the address plus 24. And then dereference that as an integer, what's the value is the same thing. Okay, just I mean, this is nothing magic, but it just help us to have a more assurance about both the concept and the correctness of your program. And then in the process, you have to do some casting. That's because I was converting a address to an integer, and then so I can plus 24, and I have to cast it back to avoid that compiler error. Yeah.
So by using the pointer to get the
I use the pointer, but I dereference to get the value. If I don't use let me just show you the program again. So the line that was I struggle a little bit is here. Is where's the line? Oh, sorry, it must be in the set pointer. You see that what I did is I cast this pointer to a long. So it became a long integer because the pointer is 64-bit. So it's always good idea to convert it to long. So then it become a long integer. So I can perform the arithmetics. I can plus 24. And then after this, you see that I casting back that. So the whole thing I just add. Now is I want the compiler to treat that as an address, not a long. So I convert it back to a pointer to an integer. And then see that star here, that's the reference. So essentially, I take one address plus 24, So I got a new value and I use casting to ask a compiler to treat that as an address, and then I reference that address. Does that make sense? I know it's a bit complicated, sorry. But yeah.
Sorry, quick question. What's the difference between long and long?
Historically, there are so many different kinds of integer type: short, int, long, long int, and long int. There's a few which is more popular. I think usually we just need to use a long, which is related to a bunch of system type. They kind of redefine that as a long, define a new type. So that's one difference, an integer or unsigned. The other one is unsigned, right? Unsigned, long, whatever. So it just has so many different kinds of data types. The key difference is usually two things. One is whether it's signed or unsigned. The second difference is whether it's 64-bit or 32-bit or 16-bit. Short is usually 16-bit. So in C or C++, we as a programmer, we cannot assume int is always 32-bit. By the way, the first time that I did the programming, int was 16-bit, short was 8-bit. So we always use the size of to verify on that particular platform what kind of the size of the value. So that makes a huge difference between C programmer, C++ programmer versus Java or Python. They never need to worry.
So Java or Python doesn't have this. This is only for C++.
Only for C and C++. Yeah, you need to verify that. I mean, of course, I believe in Java or Python, you still have short, int, and long to represent different size of integer, but you don't have the size of for you to tell that which one. Okay. Any other question? Okay, so this is I think what I hope that this file object reference.cpp will give you some either some kind of refresh about what you learned earlier, or this is the first time you learned about pointer. This is I would say my first of the two main lecture to cover pointer. I will have another maybe 2 or 3 lectures to talk about pointer when we talk about virtual function. After we finish inheritance, we have to talk about virtual function. Virtual function is the C++ way of implementing a concept called polymorphism. And over there, we need to revisit pointer. It is really interesting topic. You can see that it's challenging, but once you learn this concept, it will be really good for you for next 40 years of your programming career, okay? All right. Anyway, let's move on to the next topic. I was thinking about talking about the separate compilation, that why I want to have GPS.h and GPS.cpp separated. We will talk about that after I finish what I'm going to talk to you right now. So what I'm going to talk to you right now is related to homework 2. So this is probably the first lecture, and I will use this set of code under CPP03 for at least 2 lectures, maybe 3 lectures. Okay, which then this will be the main topic, as well as object reference, the whatever we just talked about. This will be the key content for your next midterm. Okay. All right. So I already uploaded. I believe so. Let me just show this. Okay, so I already uploaded this right before the class, CPP03 homework 2 reference. So let me just conceptually explain what homework 2 is asking. So homework 2 basically is a modeling homework. Modeling homework means that I have some situation in real world. How do I represent the information I need to process that within within the real world using the program like a C++. So meaning that we're going to define some class to capture information. And that information in homework 2 is called record. So for example, I'm currently here. I have 2 devices. This is the Pixel 4, which is the Android phone, and this is my JLab. Okay, so I have 2 devices here with me. So I want to represent a bunch of events with different time, different location, and different person they were there. So we use the concept of record. I'm going to start with record. And of course, record will refer to other class such as person.cpp or gps.cpp or thing.cpp, those things. But let's take a look at the record.h. So a record you can think about is a class I define to capture certain event. And over here, the event we have is that we have 4 things we need to capture. Oh, okay, by the way, when you really apply, when you know about operating programming to the real world concept, I believe the real world concept has a lot more things you need to capture. Not just about thing, person, and the time and the location, you might have other things. For example, when you click a like on, say, Facebook, so you can think about that's an event because you click a like, where you are, where did you click the like in TLC, when did you click it? This afternoon at the 3:45 p.m. And then you have to think about what is the content you're clicking. So that content will represent mostly by URL. So you can think about that's an event that's being captured. At least that's what Facebook captured when you use a phone. By the way, Facebook also probably capture what kind of device or which version of the software when you actually do this. So there is a lots of information being collected as an event. So we're in homework 2, we're trying to make a really simple event, only capture some specific thing. Okay. All right. So let's take a look at this. How do I define class record? So what I also want to say, the other important message about homework 2, because it's a design homework, design with your implementation, of course, it doesn't have a definite answer. So meaning that you can actually design things differently. As long as you feel that's the best way to represent the information, and that's the best way to provide some kind of extensibility that you can use this particular design to capture a broad range of events, then that's a good design. There's not really saying that which design is definitely correct or optimal. It is really based on your experience. Okay, so let's take a look at the record. Inside the record, I have a few private members. Let's take a look at this 2. These 2 are probably easier. This is number 3 and number 4, which is basically say, what's the location of that event? I'm using our famous class, GPSTD, to represent. And then when did this event occur? So I use JD time. Okay, so that you probably already have it from CPP01, both the GPS location and the time over there. Okay, that's fine. So you can see that the variable name is where and when. Okay, now we're going to look at the people and the things. So now you see that I'm using something called STD vector. Okay, that's something new I want to discuss with you. So STD column vector is something we call a standard template library. It has multiple data structure, but probably vector has been one of the most popular because it's almost identical like an array. All right, so essentially what we're saying is STD vector person, who person. So let me parse this a little bit. Did I have? Yeah, I actually already have here. So to look at the whole thing, the detail about this particular template, we usually go to the web. There is a page to reference almost everything, and this is the STD vector. It has all the detailed information about what they have, what function they have, and what's the member function, what's the interface. But that is a reference. If you want to check out everything, you should go to that website. But now we're going to show you something really simple that you can start using vector without knowing all this glorified detail about the feature. Okay, so let me actually tell you the syntax. The syntax is, I want to define, think about this. A vector is an array. Think about array. So essentially we're saying that, okay, I have to say, okay, I have the way to say this is an array. That's why I said STD vector. Whenever I say STD vector, it's an array. But I could have an array of integer, or an array of floating point, or an array of objects, or an array of pointer to something. I could have any of those. So I need to specify what should be the element type in each of the element of the array. So the syntax is like this. You say STD vector, and then you use a smaller sign and the greater than this two. Between these two, you put the type of the data type of the elements in this array. And then after that, you basically specify what is the array or vectors variable name. So let's take a look at this line. STD vector, and then inside this smaller than and greater than is person. And then the variable name is who person. So let me just summarize what we just did. What we just did is we declare an array, and that a vector. Now I should actually not use the word vector because there's still some difference in terms of the interface between the vector and the array. So I define a vector, and that is a vector of person. And then the name of that vector I just defined is called who persons. Okay, let me repeat it again. What I just did in that line is I define a vector of person, and I call that, give the name called who person. So the variable name is called who person, is a vector of person. Okay. Any question with this definition? Yeah.
So if you were to like simplify this and just like say I wanna put, if I like understand correctly, if I say I wanna put like a number of something in there, like number of apples, I would say like STD vector, and then diamonds int, and then number of apples.
That's right.
Okay.
Yes, you can put it in there. Yeah. If you put in, that is a vector of int. And by the way, I want to challenge you now. This is a little bit could be interesting. What happens if I want to put a vector of pointer, a vector of pointer to a person? My person is type, and the pointer to a person is also a data type, right? So how should I represent the idea if I want to define is a vector of a pointer to a person? Since we just talked about pointer. Yes, in the back. Exactly, that's correct. So if you want to do a person pointer, you just do this. Okay, so so you can see that when you do a person star, it's a pointer. Pointer person star is a data type, it's a pointer type. I can make a vector of a pointer as well. Okay, so it's really general. You can use this to whatever way you want to use in your, based on your whatever the C++ data type that you already know. You can actually always put it there in between this small than and bigger than. Okay, so that's the vector. Okay, now you know how to declare this. I will later show you how to use it, how to add an element to the array, how to maybe remove it, or how to retrieve each of them. That's my objectives for next 5 minutes. That's impossible. Okay, so if I cannot finish, I'll leave it next time. So the other thing, of course, is STD vector thing. So let me do this. Let me focus on person. I want to, for the next 6 minutes, I want to do 3 things. One is, how do I add an element to the array? Okay, how do I add an element to the array? And the second thing is, well, how do I, given a vector, how do I iterate through every single element in the vector? Okay, first, I want to tell you that I define a member function called add_who. You see that I'm actually adding a person to my event, right? I have to have that function for me to do that. You can see that I'm using person_p to do that, okay? All right, then I have a function which I start telling you is called dump to JSON, which you heard about that. This is the first time we're going to start to see why we need this function called dump to JSON. But today I'm just want to show you how you can iterate through each of the vector. So let's first take a look at record.cpp. So first is add_who. So add_who, let's look at this. There's only one argument. This is called by value because I want to make a copy, so I keep it in the event. It's a different copy. That's fine. And the thing is that what was the variable? What's the vector? The vector is who_person. So I said this to the who person that this is the vector. I just declare in the .h file, and I use this function called pushback. So pushback is basically insert an element at the end of the array. So I don't worry about where do I insert this element. I mean, you could do that. There is another function called insert, but insert is needed when you want to have a sorted array. But in this case, in the vector, I don't care about the order. So I just basically use the simplest way, because this is the simplest way to add an element to a vector, pushback. Okay, so with this function, then I push back this particular element to that particular vector called who persons. Okay, so if I do this multiple times, that means I might have a multiple element in my vector. So how do I retrieve each one of them? So now let's look at dump to JSON, because that's the place where I use it. So let's take a look at this part. Think about how similar this to a C array. Okay, this part, you can see that I declare a index I, and I use for I is equal to 0. And then I have a function called this pointing to the who person. Why is it this to the pointer? It's a vector. And a vector has a member function called size. So size is almost a really common way to address this issue. Not just in vector, but they're using in JSON, in a lot of other data structure to represent the number of elements in this data structure. In this case, this data structure is a vector. So essentially, this who person dot size is returning an integer. That integer represents how many elements you have in this vector. So you can see that now I'm using I is equal to 0, I is equal to this. So I indexing through every element through this, and then see how I actually refer to each of them. I use this way. You can see that this is a this who persons I. So when you use a vector, this is exactly like the syntax of a C array. You just use the bracket to say which element, from 0 to whatever element you have, right? That's the one. Okay, so I'm going to just have about 30 seconds. I'm going to show you the result of the program so you can see what's going on in this event. No, I don't want to do this. So by the way, you can compile, you can run it. This is already uploaded. Let me just make sure everything is okay. So I compile it. And then I'm going to run it. Okay, so take a look at this. It says who is a person. That person is basically Felix in this case, okay? And then there is a when. Apparently this time string has some issue I need to fix. I just noticed that. And then there's a where. That where is what? This label. This, by the way, this address should be TLC. I will actually talk about this info issue next time. But this is the address. This is the TLC. This represents the first event homework 2. And then look at what? What is an array? The array has 2 elements. The first element is a phone, is a pixel phone. And the second element is the JLab, your phone. And the thing is that, what's this representation? You probably see it first time, never see this before. This is called JSON, JavaScript object notation. Okay, we're going to talk about this, and you can really nicely represent the information. Okay, see you on Friday.